Sure, happy to do so. I think some of you have already seen on Monday, so I'm trying to do this relatively brief. So on Monday we've been talking about heat waves. So we've been saying that some events that we've seen in the recent past were so extreme that we only found them when running the model for many years, and we tried to ask the question, how bad could it really get? And so what we did is we produced first large sets of simulations, and then we went in and took one of the worst case or some of the worst in nearly 1,000 model years, and then restarted the model a couple of weeks, so 1 to 2 weeks before the actual event occurred, and added a tiny perturbation, so to get large ensembles, so many realization of that worst event, nearly worst event. And by doing this, we were efficiently sampling the most extreme events that we could think of. And we did that. We had done that for very hot extremes. And then I think from an earlier stakeholder workshop where my colleague Sebastian Sippel participated, there was one of these energy stakeholder workshops. There was the idea that why are you only looking at the hottest cases? Why not also at very cold case where we have a big electricity demand? And this basically made us think whether we could do something like this. So we this was sort of joint effort across many XAIDA work packages. Some asking the question, how would the coldest winters of the last decades turn out today? The year 63, for instance. So we've been looking at this and asking the question, if we had the same weather conditions like in the year 1963 here shown in the top right, how would this event turn out today? And the other thing is we exactly did what I just described, but did it for winter. So what you could see here, the gray are if you run the model many years. So we're looking at winter periods in many realizations. And then we already had one very cold winter, which is shown here in light gray, which just happened to be a complete outlier in the model. And we thought, okay, this is one single winter. Can we reproduce more of this efficiently by doing what I call this ensemble boosting method? And what we did is basically we started the model at the 1st of December, and from a case which already was very cold and produced many realizations. This is shown here in light blue, and you see many, some of them. So we had got a large set of simulations which had a very cold December, and then at the end of December or early January, we took some of the coldest of this and started them again. And this is the medium blue, I guess I call it, where we continued and produced trajectories of very cold winters. And then we went in to study them and studied the atmospheric drivers and found so that one of the conclusion is the probability of having such a very extreme cold winter is substantially lower than it used to be, but this event would still be possible today, and they would be substantially amplified by feedback. The fact that if it's cold, we get more snow. If there's snow, we have higher brightness of the surface, we have higher albedo, so we reflect more sunlight, and this has a feedback like in summer through soil moisture, but the other way around. The snow would make it even colder. So the bottom line is basically we would have trajectories here for very cold, very cold winters. So if anyone is interested to run this, say through a energy model or something like this, we would have data. And the paper is now in discussion, and it's actually open access. I'm going to share a link in a minute. This is how it looks like. So you're most welcome to have a look, and also give still feedback, because Sebastian is still revising it.